So here we are going to implement LiveStockIQ is an innovative application designed to showcase the power of integrating live API server with AI to retrieve real-time stock prices. This app leverages the RAG, which is Retrieval-Augmented Generation framework, with an API-based retriever. Here is how it works. So this is the dashboard of LiveStockIQ app. This app leverages the RAG API-based retriever to provide real-time stock insights. At the top, you see the app's title, showcasing its purpose to retrieve stock prices, stock charts, and answer general queries. Users can start by entering their query in the provided text box. So for example, user could ask, what is the current stock price of Tesla? So it is now fetching the current stock price of Tesla using API-based retriever. So it has connected to an API server and retrieved the livestock price, and the retrieved price information was passed to the generator along with the user query, and the generator part of the RAG generated this response for the user. Now, user could also ask, say, show me the daily stock chart for Tesla. So this time, this app will again connect to the API server, but this time it will fetch the daily chart, and then the generator model or the generator part of the RAG pipeline will generate this response for the end user. All right, now let me walk you through the implementation design of this use case. So we have these key components. We have query analyzer, retriever, generator, and API server. The flow begins with the user submitting a query. The query analyzer processes the query to determine user's intent or category. For instance, it might classify the query as being about general knowledge or livestock price query. Based on the query type, the system decides if the query requires fetching live data from an external API server. If needed, the query is passed to the retriever. If the query is not about the live data from the API server, if it is about the general knowledge question, then the query is directly submitted to the generator. Imagine if the query is about the live stock price, then the retriever interacts with the external API server to fetch the relevant data from the API server. The retrieved context from the API server is combined with the original query to form a context-augmented input. This ensures that the system has both the user's intent and the relevant live information. The generator uses this augmented input along with the prompt instructions to generate a coherent and contextually accurate response. So finally, the generated answer is returned to the user, incorporating both the query and the dynamic data retrieved from the API server. This flow highlights how an API-based retriever enables RAG systems to provide real-time and contextually rich responses, making it ideal for queries that requires dynamic or live data. All right, so now let me walk you through this code. So these are the libraries which we are going to use. So we need to import these libraries. I will talk about how to create the setup and environment later, but let us first walk through the code. So here, Streamlit is a Python library used for creating interactive user-friendly web applications. So we are importing that. Then we have this requests library. So this is a library for sending HTTP request in Python. So it is used to interact with external API server. In this case, to fetch the live stock price or to fetch the latest stock data, we are integrating with AlphaVantage API server, which is third-party API server, which provides the livestock related information. So AlphaVantage is the API server in this case. Then we are going to import the OpenAI library because we are going to use OpenAI APIs to use their GPT models. We are going to use GPT-4 Turbo model, and that is why we are going to import this library. Then we have this .env. Now, this is the library to load environment variables from a .env file. So here you see we have created a .env file. Now, in the .env file, we are storing our OpenAI API key, and also we are storing our AlphaVantage, API key. So this key need to be stored in the .env file so that you don't need to hard code this in your code for security reason. You need to generate your own key. So you need to go to OpenAI web page and then you generate your OpenAI API key and configure it like this. And then you also need to go to AlphaVantage web page and then you create your account and you generate your AlphaVantage API key and configure in this .env file. All right. Then we are importing OS. So OS is a standard library in Python for interacting with the operating systems. So it helps in accessing, say, the environment variable. It also helps in handling file path or directories if needed for data storage or retrieval. Then we are importing Pandas. Pandas is a popular data manipulation library. It helps in handling tabular data, for example, time series data for stock charts. It also helps in converting JSON responses from the API server into data frames for easy processing and visualization. Because the API server is going to return the response in JSON format, and therefore it will help us to convert that JSON responses into data frames. Then we are going to import Plotly. Now, Plotly Express is a library for creating interactive data visualizations. It helps in generating charts like line chart, which we are going to implement to visualize stock price trends over time. It enhances user experience with dynamic interactive visualizations. So like we need to display daily, weekly, or monthly stock charts. So this will help us to do that. All right. Now here we are going to read our API keys. So we have, remember, we have .env file where we stored this OpenAI API key and AlphaVantage API key. So we are going to read those API keys here. Okay, I think we need to remove this. This is redundant. All right. So here we are going to, get those API keys. Now this OpenAI API key, which we just retrieved here, is going to be used to create the OpenAI client object. So using this client object, we will be calling OpenAI APIs. And then using this client object, we will be able to access their GPT models. All right. Now, this is the base URL or the API endpoint for AlphaVantage API server. Now, this part of the code defines a dictionary named company to symbol mapping, which serves as a mapping between company names and their respective stock symbol. Now, what happens is that the user, when the user will type the query, user don't remember the company symbol which are listed in the stock market. The API server understands these symbols. Okay, API server don't give you the results based on the actual company name because they understand the stock symbols, and therefore we need to maintain this mapping so that when user asks any question, user will provide the company name and not the stock symbol, and therefore we need to, using this dictionary, we will pull the corresponding stock symbol so that that stock symbol is passed to the API server. All right. Here, in this use case, we have only added these 5 companies, but you can just keep on adding other companies which you wish to have. All right. Now, this is the query analyzer. So you remember in our design, there were a query analyzer box, which is supposed to receive the user query. So the query analyzer function acts as a brain of the application. So it uses OpenAI GPT models to classify the user's query into one of the following categories, like whether the query is for stock price or queries for stock chart or queries for general query. So this is the prompt instruction. this prompt instruction you can just read through. It says that classify the following user query into one of the 3 categories. And then it says that the query is about stock price or charts. Also extract the company name and the chart interval if applicable. And then this is some few short examples which are given. So the key feature of the query analyzer is this few short prompts. The analyzer uses a structured prompt to guide GPT in GPT model. In this case, GPT 4 Turbo, which we're going to use. So it will help the GPT model in classifying the query and extracting the relevant details. This prompt helps the GPT model to focus on extracting specific details like category or company name or interval if the query is about daily, weekly, or monthly. Then here we have this part of the code where you see we are calling the OpenAI APIs using our client object. Then we are configuring the model. So we're going to use GPT-4 Turbo model. And then we have this message list where we are passing this prompt instruction. In the prompt instruction, you see this is the prompt instruction. And then in prompt instruction is appended with the user query. We are setting max token as 150 and temperature as 0.7. And then the response is collected. Then based on the response, then now we need to retrieve the category. So the response will have category, the response will have company name, and then the response may have the interval, right? So we need to extract all these informations from the response which we're going to receive from the GPT model. And once we have this ready with us through this part of the code, then we are going to pull the company symbol using the company name. So remember we defined a dictionary here, company to symbol mapping. So here we are going to use the company to symbol mapping dictionary. So dot get, so the dictionary name, company to symbol dot get, and then you pass the company name, it will provide you the symbol. Now, once we have this, then we are going to now finally return the category, the company name, the interval, and the symbol. This is just the error handling part of the code. All right, so we talked about the query analyzer, the first block. Now let us talk about the retriever. So here we have retrieve stock price is the function where we are implementing our retriever. So let us walk through this part of the code. This function is designed to fetch the current stock price of the company using AlphaVantage API. It retrieves the live stock data for a specific stock symbol provided as input. So if you see here in this function, we are passing the stock symbol, right? And then what we have these parameters. Now these parameters is expected in the API call. So this is the API requests parameter. Here the function, which is the global code, specifies the API function for fetching the latest stock code. Then we have symbol. Symbol is for the desired stock. And then you need to also pass the API key, which we have extracted from our .env file. All right. Then this API request. So this is the actual API requests which we are making. So requests.get, and then you pass the base URL, which is the endpoint, API endpoint of the API Vantage, which we have defined here. So you pass that, and then you pass these params, which we have just defined. Then the API server is going to provide you a JSON response. So the response will be in the JSON format. Now we need to parse the response because this is in the JSON format. So response.json converts the API response into a Python dictionary for easier processing. The JSON data typically includes the stocks metadata and the latest quote. So once we have this data converted into, say, a Python dictionary, then we need to extract the stock price from that dictionary. So how the dictionary looks like. So let us see how the dictionary looks like first. So the JSON response looks like this for the global quote. So here you see in the global quote, we will be receiving these as a response. Now here, the fifth place is the price of the stock. So this part of the JSON response contains the current stock price. Now we need to, retrieve the current stock price from this part of the JSON response. So to retrieve that, we need to, just do data and then use this global quote, and then you have to use this 05 dot price, and then you will get the actual price of that stock symbol. All right. So the retrieval of the livestock price is done. Now let us move to another retriever function where we are going to retrieve the stock chart. When user will ask, show me the daily chart of, say, Tesla, then this part of the retriever code will again call the Alpha Vantage API server, but this time it will pass the stock symbol along with the interval which user has requested. So interval could be daily, weekly, or monthly. So let us go through this part of the code. We need to determine the function type which we are going to use to retrieve the historical stock data. So there are these functions so defined in the Alpha Vantage. So for daily, you need to pass the time series daily. For weekly, you need to pass time series weekly, and for monthly, you need to pass time series monthly. So this is the function defined in the API Vantage server. And then this is the function parameter. So we need to pass the function which we're going to call, then we need to pass the stock symbol, and then we need to pass the API key. And then we are going to call again the requests.get method. We are going to pass the base URL and the params. And then we are going to get our response. Then here we need to extract the relevant time series data from this response. So this part of the code explains that. So let us try to understand. Now here the key is basically defines the key which are part of the response. So in the response you will have these keys, something like time series daily, weekly time series, and then the monthly time series. So you need to identify the key based on the user query. So the user query may contain the daily, weekly, or monthly. So then based on the user query, you identify the key. The data under this key contains the stock prices for each date. Now we need to convert this data into pandas data frame. So once you have this data extracted into this time series variable, then we need to convert this into Panda data frame like this. And then this part of the code here is just renaming the columns for better readability. Okay. So here we are just renaming the columns. Then here we are just, converting the index values, which is dates in string format, into date time objects for easier manipulation and visualization. Okay. And then we are going to, sort the data. So here the data is actually sorted in chronological order to ensure that earlier dates appear first in the graph. Okay. The sorted data frame is returned for further processing or visualization, right? Then we have the final block, which is the generator. Now the generator function handles the general queries, right? So as you remember in the flow chart, the queries was categorized into general query or the stock related query to fetch the livestock data or historical data, which goes through the retriever, or if the query is general, then the query is directly routed to the generator. Now, the generator has a prompt instruction which says that you are an AI assistant. Below is some context. So here the context is provided along with the user query. Then we are going to call the OpenAI APIs using our client object. We are going to use GPT-4 Turbo model. And this is a message list through which we are going to pass the user prompt. And the max token we are setting as 200 and the temperature is 0.7. And then we are going to get the response from the generator. And then this response is returned to the user. All right. Then this part of the code is about the dashboard, the visualization, which is implemented as a front end for the user. So the front end provides an interactive user experience with the following key components. So it has, of course, it has title and then the description, and then there is a text box where user actually writes the query, and then there is a submit query button which you have seen in the beginning. So it has a submit query button. Now, the app waits for the user to click on the submit button. Once user is provided the query, user has to submit the query through the submit button. And when user clicks the submit button, then the processing of the query starts. So then it goes through the query analyzer. Query analyzer analyzes this query, and then based on the category which is defined in the query analyzer, so it could be the stock price related, or it could be chart related, or it could be general category query. So based on the category, the different retrieval function is invoked. So for chart related query, the retrieve underscore stock underscore chart is invoked. For livestock price, this retriever is invoked, and for general query, directly the generator is called. All right. So this is all about the walkthrough of the code. You have already seen the functioning of the application in the beginning. The whole bunch of this code will be placed into the GitHub, and I will also provide the link in the description of this video so that you can access the repo, get the code, do the setup on your local machine, and just get going. So here, this is the code repo on GitHub. On GitHub, you can just go on this page, Data Science Champion and Zero to Hero in NLP, LLM, GenAI, AGI, and here you try to either clone the code repo using this URL, or you can directly download the package, the whole directory. And when you download that directory, so you have to go inside this RAG. So for LiveStockIQ, you need to go inside this folder, and then there is this README file which helps you to do the setup. So you need to just follow the steps mentioned here, and then you should be able to do your setup and then run your use case locally. Link of this repo will be provided in the description.